Hi all, welcome to the video. In the last video for statistical analysis, we looked at probability density function and cumulative density function of a discrete random variable. In this video, we'll look at what is a continuous random variable in terms of density functions, and we will again take a very simple example, simple and intuitive example, so that we are able to understand. Uh, so first of all, if you recall, the most important difference between a discrete random variable and a continuous random variable is that discrete random variable is defined for fixed number of events, like whether the computer is going to crash once, twice, or thrice during a CAT examination. However, continuous random variable is basically defined for any number of values, like uh, let's say how much time will it take to travel from home to office on any given day. It can take any time, right? It can take 15 minutes, 20 minutes, 15 and a half minutes, or 35 minutes, and anything. So uh, just to look at, if we basically look at the probability density function, again, to make it simple, it is defined, or it is treated in the same way as discrete random variable. And for this example, we are taking the time taken from, let's say, home to coaching center, or from home to office. Just to make things simple, we are trying to create a bell-shaped density function similar to a normal curve. And if you look at the x-axis, this is nothing but the commuting time in minutes, and on y-axis we have the probability. Now the most important thing for a continuous random variable is the function is not defined at a point, it is only defined in an interval. Meaning, so let's say the event can be, what is the probability that the commuting time is less than equal to 15. Basically the range here, or interval here, is between 0 and 15 minutes. So let's say the probability is 0.2. Another range can be, what is the probability that the time is between 50 and 20. And then another range can be, what is the probability that the commuting time is greater than 20. So for all these cases, if you add up the probability, it sums up to 1. Now, if we basically add probability at each step, or if we add the probabilities for different interval at each step, we basically get a probability density or cumulative density function, as shown in this graph. Again, as we uh, go across time on x-axis, the curve basically increases and then eventually flattens out for higher values of commuting time. I hope this video was useful to you. If you like the video, do subscribe to my channel.